Have you ever wondered what goes on behind the scenes of a big scientific discovery? I mean, we always see the final published paper, but what about the whole story? Today, we're going to dive into a new model that wants to capture every single step of that process.
And this quote, wow, it just gets to the very heart of it. Science isn't some clean, straight line to an answer. It's messy, It's full of collaboration and debate. But the problem is, all we ever get to see is that super polished final result. So you gotta ask, what happens to the actual foundation that everything is built on?
Think of a published paper like the tip of an iceberg. Sure, it looks impressive, but what we're not seeing is the massive amount of work happening under the surface. I'm talking about the failed experiments that taught everyone what not to do, the late-night debates that refined the ideas, all the little annotations in the code, all of that incredible, valuable knowledge, poof, it just vanishes. And it creates this huge gap between how science actually gets done and the neat little story we read at the end. So, okay, how do we fix this? How do we actually save that whole hidden part of the iceberg? Well, the solution is to completely rethink what a scientific contribution even is. So instead of one giant block, imagine building knowledge with tiny individual atomic bricks. And that's the core idea of an atomic contribution. Instead of waiting to publish one giant paper at the very end, you capture every single part of the research process as its own small, citable unit. Each piece becomes a fundamental, digestible building block of knowledge. So you're probably wondering, what really counts as a brick? Well, it can be almost anything that's part of the scientific journey. It could be your initial hypothesis, the specific method you developed, the data set you spent months cleaning up. That's a brick. A snippet of code? A brick. Even just a really insightful discussion point from a lab meeting. Or, and this is so important, a failed experiment. Each one is a valuable piece of the bigger puzzle. But here's where it gets really powerful. These bricks aren't meant to just sit there by themselves. No way. Each one is designed to be traceable, so you can see exactly where it came from. They're reusable, so other scientists can grab them and build something new. And most importantly, they connect to each other, forming this incredible dynamic network of knowledge that's always growing. Of course, if you're breaking science down into all these tiny pieces, that raises a pretty big question, right? If anyone can contribute, how on earth do you maintain quality and trust? Well, this new model has a fascinating answer for that. And this is the crucial question, isn't it? If anyone can just add a brick to the pile, how do you stop the whole system from being flooded with unreliable info? The answer is all about shifting how we approach validation. Just think about the difference. Traditional peer review takes months, sometimes years, to evaluate a massive paper, and it's mostly focused on the final conclusion. Atomic validation is totally different. It's fast. It's granular. You check each brick individually. Does this code actually run? Is this data set sound? The focus shifts from just the final conclusion to total reproducibility. It's about making sure the entire structure is built on solid ground. And this has massive real-world implications. Imagine an industry team that needs a solution, like right now. Instead of digging through papers, they can just pull a verified brick of code or data that's ready to deploy. And here's the key. Their feedback, whether it works or not, becomes a new brick, instantly enriching the network and closing that gap between research and reality. Now, to make all this seamless, there is AI-assisted guidance to help researchers create and connect these bricks. It kind of acts like a smart assistant, making sure all the key details for reproducibility get captured, even the small steps a researcher might otherwise forget. This helps align everyone's work with best practices like the FAIR principles: findable, accessible, interoperable, and reusable, building a truly robust knowledge network. Okay, so a great idea needs a great incentive structure to really take off. So how do we fuel this ecosystem and actually encourage researchers to contribute their best, high-quality bricks? This is where the model gets really clever. It creates this rewarding collaboration cycle. When a researcher publishes high-quality validated bricks, they actually earn travel credits. They can then use these credits to go to conferences or visit other labs, share their work, and forge new collaborations, which, in turn, leads to more new bricks. It's a fantastic, virtuous cycle. And the whole thing is self-sustaining. That pool of travel credits, it's funded by organizations, like those industry teams we just talked about, that subscribe to get access to this incredible network of verifiable, accessible research. So it really is a win-win for everyone involved. So what does all of this add up to? What's the ultimate vision here? It's really about building a new kind of science, one that breaks down the walls between individual labs and different institutions. When you get right down to it, by preserving the entire process, this system does way more than just archiving information. It transforms all of those individual contributions into a living, interconnected structure of knowledge, one that can grow and evolve in real time.
And the impact of that is a huge acceleration of discovery. The old cycle, from a new idea to a real-world application, could take years, sometimes even decades. With this kind of model, we could create a rapid, continuous flow from verifiable research bricks directly to tangible solutions that can change the world.
This is the vision of Science Live, research beyond walls, where every single contribution matters. It really makes you wonder, if every idea, every failure, and every small success could be shared and built upon instantly, just how fast could we truly solve the world's biggest challenges? If you want to be part of the answer, you can join the beta waitlist and help build that future.